In this video, we'll be going over the iterative approach of binary tree postorder traversal. So given the root of a binary tree, return the postorder traversal of its no values. Let's go over the dot process. So the direction of a postorder traversal is left subtree and then right subtree and then the root. We will need a way to mimic the recursive call stack memory. We can create a stack data structure to keep track of our nodes. We should note that we can traverse the tree in the following direction. We'll first start roots, and then right subtree, and then left subtree. We can see that this is essentially the reverse traversal of this. If we reverse the direction, we get the roots, and then right, and then left. So how can we reverse the ordering of the node values? When we are performing our postorder traversal or recursive postorder traversal, we added node values to the end of the list. If we add node values to the start of the list instead, we will essentially reverse the ordering of the node values. Now let's go over the pseudocode. So let's first validate the input parameter. So if the root is null, this means there are no values in this tree. We can just return an empty list. Then we're going to create two variables. The first one is a stack. It's our stack data structure to implement iterative postorder traversal. And then also a values list of all node values. We're going to push the root node into the stack first. And then while stack is not empty, this means we still have nodes to process. We're going to pop a node from the stack. Now we're going to add the node values to the start of the list instead of the end of it, instead of the end of the list. So add node.val to the start of values. Now we want to process the right subtree first, as we can see here. This means we want to process our right subtree before our left subtree. This means we want to push the left node into the stack before our right node. So if node.left is not null, we want to push node.left into the stack. And if node.right is not null, we want to push node.right into the stack. This will allow the right node to be on top of the stack. This means the next node that we're going to process is our right node. And we can return our values list. Now let's go over the time and space complexity. For the time complexity is O of n, where n is the length of the input array. Not input array, the input tree, or n is the number of nodes in the input tree. It's because we visit each node once. And our space complexity is O of n plus O of h, which is equal to O of n. Our n stays the same, and then the h is the height of the input tree. The O of n is the values list, and O of h is our stack. Now let's go over the code. So we'll first validate the input parameter. If roots is equal to null, we can just return an empty list. We'll create our two variables. The first one is a stack to implement iterative postorder traversal. And then our second one is a list of values. We're going to create a linked list because we are adding values to the start of the list instead of the end of the list. We do not want to shift nodes or node values downward. And then we're going to push our root node into our stack. And then while stack is not empty, we still have nodes to process. We're going to pop a node from the stack. Then we're going to add the node values to the start of the list. Then if node.left is not equal to null, we're going to push it into the stack. Then if node.right is not equal to null, we're going to push it into the stack. The next node we're going to process is our node.right, because node.right will be on the top of the stack. Then we can just return our values list. Let me know if any questions in the comment section below.